In this video, I'm going to show you how I fine-tuned the open source LLM using cursor and agent skills on Nebius Token Factory. In this video, I'm not going to show you the whole steps to do the fine-tuning. I will just guide you to the notebook that I have built and created using cursor. Interesting part is how much time it took me to prepare dataset, running the fine-tuning jobs and deploy the model, and then calling the same model to compare between generating versus fine-tuning responses. The question you might ask, why Nebius? Why you are not using other platform for fine-tuning? So during my research, I came across this blog, Fine-Tuning as a Service. This is a very nice blog, even a benchmark. So here you can find benchmark between three top providers, Nebius, Tinker, and Together AI. And if you look closely at this table, so I found that Nebius is the only provider offering full fine-tuning and LoRA fine-tuning as well, with proper infra to host in production environment. This is very detailed blog, and if you are looking to fine-tune models for production, you can read this blog. I will drop link in comments. The other interesting piece is how this fine-tuning was done. So as I mentioned in start, I have used agent skills inside Cursor to fine-tune the model and deploy the model. So things like batch processing, data operations, model deployments, and observability can be done using predefined instructions in agent skills. Inside Cursor, I have used agent skills plus Nebius docs to give context to AI. And on the AI part, I have used Focus 4.6 model to plan the things and Composer 2 to implement the things for this fine-tuning task. I have fine-tuned for insurance claim chatbot use case because during insurance claims, if you have an AI supported chatbot or any agent working for customer facing applications, there might be a time where customer asks weird questions related to their health or maybe critical questions related to insurance claims. When you are using generic LLM model, it might produce generic and long answers which might not be relevant to the questions users are asking. With fine tuning, you can save token cost on that customer support chatbot, and you can also provide better results, better answers to users coming with questions related to their insurance claims or tools. So I have picked insurance claim chatbot training dataset from Hugging Face, this Bytex insurance LLM chatbot training dataset, and I have used this to fine tune our LLM. So what features this notebook has, what I have implemented using Cursor. So we have a data lab pipeline where we are processing data operations, creating JSON-L for training. Then we are using a teacher model of Llama 3.370 billion to improve training targets before student training. Then we are using Llama 8B models, fine tuning as a student model. And then we are deploying the Llama fine-tuned model and then exposing as private endpoint. Now let's come to architecture or high-level flow of what's going on in Notebook. So I am taking data set from Hugging Face. We are setting baseline for a billion parameter model. Then inside data lab and teacher model is being used. Here we are uploading data set in data lab. Then teacher batch is being done, and batch inference is 50% cheaper than real-time inference on Nebius. Then after batch inference using teacher model, we are exporting and curating JSON-L data for the training. From here, we will get JSON-L data from data lab, and then we are uploading that data set for fine tuning 8 billion models, and then we are getting the fine tuned weights, which will be later deployed as private model endpoint. And from there, we can use custom model. So let me show you Nebius dashboard once where all things are happening. So this is Nebius data lab. Here we have data sets. You can see first data set was imported here. So these are the messages. These are the prompt, and this is the base completions. And you can see categories as well. So full data set is here. And then in data lab, you can also import chat completions data from the previous chats you have with your model, or you can also import external data set like object storage or file uploads. So I have used external data set of insurance fine tuning from Hugging Face. And in the observation sections, you can see what data or batch operations are being run. So you can see I have run this batch inference job. It succeeded. So I uploaded this data and output was this. You can see we have prompt completions, and then you can start fine tuning from here. I am not going to continue this because I've already done it, but if you want to, you can do it from here. Now, one important thing is why fine tuning. Obviously, you want to increase the accuracy of your model for certain use case. Let's say insurance claim in my use case, maybe healthcare, maybe banking, or maybe let's say you have a SaaS product, you want to give better answers to your customer, you can fine tune on your data set based on customer conversations. And then you can deploy that model to be used inside your applications. With Nebius, you are not paying any extra fees on GPUs or anything if you have private LoRa deployments. So once you fine tune, you can deploy the model and you can pay per token price just like other models using Nebius. This is the notebook where I fine tuned Llama 8 model on insurance claim chatbot dataset. So you can see this notebook is quite detailed. So I am not going to go step by step, but let me give you overview what happening. So here we have setup and configuration. So you can see chat-based model is 3.18 billion model. Fine-tuned model is also 8 billion model. And teacher model is Llama 3.370 billion. Now we are defining helper functions to do all these operations and jobs like OpenAI compatible fine-tuning, data export and curation, and data lab related operations. In this part, we are loading data set and splitting the data set to be used for training and test purposes. So here we are calling the base chat model to each 10 test prompts that we are defining so that once we fine tune the model, we can compare the similar prompt on non-fine tune versus fine tune model to see the fairness comparison. So here we are running batch inference. So batch needs person data set and a stable mapping from each rows back to the original user. Here we have teacher batch inference. So run data lab batch inference on the uploaded data set. This step can take long time because we are doing batch inference and it can run up to 24 hours. But in our case, we are not using the big data set. We have limited the data set to 32 rows and it will take only few minutes. Also, if you have data set prepared from before, you don't need to create this job again. You can just use the previous successful job dataset ID. Now we are exporting the teacher auto dataset, parse each record, pair prompt with assistant text, and write in chat format. So why we are doing it? Because fine-tuning API expects conversation JSON as raw batch stores can include extra fields and need normalization. So here we are doing data cleaning. In simple word, LoRa updates a small adapter instead of full weight. It will save your time, it will save your cost, and it should be enough for your use case. But Nebius also gives full fine-tuning options. So if you have a use case in production, you can do the full fine-tuning with Nebius. Now we have to deploy that model. So in this step, we are deploying the model and we are naming it something. So this exposes adapter as a serverless private model, name you can pass to chat companies that I have mentioned. Same API as the base model, different model string. API base URL will be same, but model string name will be changed. And just like that, you have fine-tuned the full LLM on your dataset. So let me show you the comparison between the non-fine-tuned 8 billion models versus fine-tuned 8 billion model. Without touching Nebius dashboard, Cursor did everything programmatically. It deployed the model. So this is the deployed fine-tuned model. So as you can see, you have same base URL as the original model. We are just changing the name of the model. As you can see, I'm using a custom model name here. So let's run our Gradio app. They start fine-tuning model versus generic model response. So this is the project tab. So you can see you have base model, we have fine-tuned models and side-by-side comparison table as well. So these are the artifacts that generated during the training. So after answers are prompt like this, an answer is looking to file life and source claims and these things. So these are the dataset related artifacts. Then you can see the before answers. Then you can see insurance batch outputs, JSON format. Then curated the training dataset in JSON format and insurance raw dataset in JSON format. And these are test prompts. So on this prompt, we are going to compare between two models. So let me ask this question to the models. So let me give the question to this. So this is non-fine-tuned model, 8 billion parameter model. So let's see what answer it gives. As you can see, it's running for quite some time and gives this detailed answer. Estimate an auto insurance code, you can follow these steps and all things. So this is good, but it's quite generic, right? Now let's check fine-tune model for the same what it says. So expectation is it should give accurate answer. So see, this is quite short and accurate. Estimated auto insurance for the information that would be required into detail about bank details. Would you like to provide some basic information or have a specific scenario in mind? So as you can see, this is crisp and accurate answer. But for this model, it burned more or two tokens to give the answer. Let's do one side-by-side comparison for different prompts. So we have test prompt. Let's test this. I got to cancel my auto insurance policy. How can I do it? Now let's give message to both at once. So this is base model and this is fine-tuned model. As you can see, base model gives very detailed answer and it doesn't make sense. As you can see, base model did give a detailed answer, but I'm not sure if it's useful for customer because it's generic answer. But here you can see, cancel your policy. I will need some information to proceed. Can you please tell me your policy number or the phone number linked to your account? So if you are a company, you want to give this kind of answers to customers so that they don't get confused with your answer. But here it has a lot of things. So next steps after cancellation, next step you may be asked because this LLM has no context. Base model has no clue on how to answer your customers based on their requirements. But the fine-tuned model is quite accurate in having conversation with your customer. Before ending this video, let me show you the Nebius dashboard once again, final time. So this is the dedicated endpoint, private endpoint I deployed after fine-tuning. You can also see observability for dedicated endpoint. So if you deploy a dedicated endpoint for your use case, you can choose the model, you can choose the reason, and you can pick the base or fast. Then GPU you can pick, and more options you can pick from reaching out to customer support, I guess, and you can deploy this private, not private, like dedicated endpoint. And when you use dedicated endpoint, you can get observability related to it inside this dashboard. This post any parts shows jobs running or completed or cancelled. So I have fine-tuned, I have run these fine-tuning jobs. You can see these are completed. And the estimated cost is just $0.02. So it's quite cheap as well. To give you a quick recap, we have used agent skills, we have used Cloud Plus 4.6 and Composer 2 model side cursor to build this. Thank you for watching this video.